Vishnu Mohan T, an eminent scientist working at the BARC Atomic Research Center.
Mr. Vishnu Mohan T is an expert in the field of astrophysics and has been studying asteroids for several years. We are so grateful to have him here with us today to share his insights and knowledge on this fascinating topic.
Join us as we gain insights into the fascinating world of asteroids and their significance in the realm of science. We welcome you, sir.
Why do asteroids appear to be irregularly shaped rather than being spherical like those of our planets?
Hi, before starting the session, I would like to express my sincerest gratitude to the management, teaching staffs and students for giving me this opportunity. So coming back to the question, why asteroids are not in a spherical shape or related to the spherical shape of the asteroids. See, a lot of parameters contribute to the shape of an asteroid. First thing we can say is the formation, how the asteroids are formed. Normally, asteroids are formed by a process called accretion, where slowly the matter gets accumulated over a period of time. So this accumulation of matter may not be in a systematic way or in a particular time. Actually, it is an ongoing process. So because of this process, it may be uneven distribution of mass. So that is one parameter. And second parameter that we need to consider is the collisions. Asteroids, as you all know, collides with each other and also with planetary systems. So because of this process, a process of accretion happens, means a part of the matter get displaced or move away from its surface. So again, craters get developed and this will result in an uneven shape. And third parameter that we can consider is its weak gravity. See, asteroids when compared to planets, for example, 0.002% of planet's weight, that will contribute to asteroid's mass, you can say. So weak gravity will have an impact on its shape too. Suppose if the gravity is very high, then it will pull the matter into a spherical shape. So sphericity of an asteroid will be very less. For example, point.
How are asteroids classified and what are some of the notable types of asteroids?
The question is on the classification of asteroids. You can just say that there are two prominent classifications that has been followed worldwide. The first one, which was developed by David J. Tholen, is Tholen taxonomy. It is based on the spectral characteristics of the asteroids, and it definitely gives an indication of the composition of the asteroid. Based on this, around 14 classes has been defined. And you can say of the prominent of these Tholen taxonomy includes M-type, S-type, C-type. For example, C-type is nothing but carbonaceous type, M-type is nothing but metallic type, S-type is nothing but silicate type. So the second classification that is developed was second classification that has been developed is Best-DiMaio classification. That it is a kind of refinement of Tholen taxonomy. Here the asteroids are classified into 26 types. So but here instead of spectra, emission spectra, it is reflectance that is taken into consideration. For example, X type, L type, V type, etc. X type will have a high albedo. Albedo is nothing that range to which light is reflected from the surface of the asteroid. So X type is there, L type is there, V type is there. L type will have low albedo. So further refinement and research is in progress. So maybe it will get developed and further refinement will be done later on.
Scientists study the composition of asteroids and what have you so far learned about the chemical makeup?
Chemical composition or chemical makeup of asteroids, how we are coming to know about that. Let's see, a lot of techniques are in use in the world. The majority of them are done with the help of spectroscopy. Spectroscopy will give a clear indication of its composition from the emission line, absorption line, reflectance lines, etc. That will give a clear indication what are the elements, for what elements these asteroids are made of. That is one thing. Then second thing you can say is telescopic observations. Highly refined telescopes are available nowadays which will give a clear idea of its surface, and that will also give an idea about the minerals that is present in the asteroids. And third one, which is a very good developed one, is spacecraft missions. Spacecraft missions will help us to get matter from an asteroid, analyze it, and will give a detailed analysis will give a clear idea of what these asteroids are made of. For example, NASA's Shoemaker mission, which was the first man-made spacecraft, which was the first spacecraft to land on an asteroid, Eros, and it has collected data. It gives a good indication of what its structure is made of. So that is the third one. And fourth one is meteorite analysis. Most of the meteorite that falls on Earth are part of asteroids. So direct analysis of these meteorites will give an indication of what these asteroids are made of.
Can you discuss the role that asteroids have played in the history of solar system, both in terms of their impact on other celestial bodies as well as potential sources of life-supporting elements?
Yes, definitely. Asteroids have played a significant role in the history of our solar system, both in a constructive and a destructive way. Speaking of the destructive way, you may know that when an asteroid collides with a celestial body, it will create a major disturbance, shaping the geology and altering the atmosphere of planets and moons. For example, a notable two events we can say is the formation of moon. It is believed that the moon has been formed when an asteroid has collided early Earth. So that has definitely changed the geology of the early Earth at that time. And another one which we all heard of is the extinction of the dinosaurs around 65 million years ago. It is believed that it is because of an asteroid collision on Earth. So in a constructive way, you can say that it has always been helpful in the development of the planetary systems. It by supporting life-supporting materials like amino acids, that is by the carbonaceous asteroids, and also highly volatiles like water, organic compounds, and other elements. Asteroids, asteroids have always influenced the development of planetary atmospheres, hydrospheres, and always helped in the potential development of life.
What are some of the potential risks posed by asteroids, and especially on those who collision with our Earth, and how might we mitigate these risks?
Potential risks by asteroids, definitely. First, you can say that it's an impact damage. Suppose an asteroid collides on a planet's surface, huge amount of energy will be released, and this on collision, shockwaves will be generated, widespread destruction will happen. And again, this can be a localized event or can lead to global consequences too. So that is the first one, you can say, impact damage. And the second one you can say is air burst or blast waves, you can say. See, suppose a small asteroid enters into the atmosphere, it will experience extreme heating, and because of that it may explode also. This will cause shock waves through air, that you can say that air burst. One of the events that which is very famous of this type is 1908 Tunguska event in then USSR. 1908 event that was. It produced a huge destruction in that Tunguska area. Third one, you can say it's a tsunami. Suppose if an asteroid fall into a water body, suppose an ocean, it may result in tsunami generation, and this will in turn destruct these coastal areas. So the major mitigation strategies that is being followed worldwide is one is deflection. That is the first strategy. Deflection, as the name suggests, it's to deflect the asteroid's pathway. Suppose if an asteroid is coming into collision to a particular area, what the scientist will do is to send a spaceship, and this will have a directly interaction with. It can directly interact with these asteroids, so that its pathway will be changed.
What role do you believe asteroids will play in future space exploration and commercial endeavors, particularly on those of resource extraction and asteroid mining?
Coming to the answer of the question, so regarding the tracking of asteroids through space. See, normally, as we all know, the first major development that has been used are telescopes. So one of the telescopes that we have seen throughout our school's career or school studies was ground-based telescopes. But now there are advanced ground-based telescopes which are in such an advancement that they will be able to provide spectrographs even of the asteroid. So this will give a detailed insight of the asteroid surface, and based on multiple images that we capture using these advanced telescopes, we will be able to plot these apparent motion of these asteroids for various period of time. And also this information will help in determining the asteroid's orbit and predict its future path. That is a very important thing, and it is widely used all over the world. Now the second advancement you can say is radar observations. Radar observation, as the name suggests, it's nothing but radio waves will be emitted from a source, and it is expected to get reflected from the asteroid surface. So again, this will give a detailed insight into the surface of the details of the surface of the asteroids. Then but it is much more precise measurements. It will give much more precise measurement than of the ordinary ground-based telescopes. And the third one we can say is space-based telescopes. Here, the major advantage is that it's above the atmosphere, like Hubble's telescope. It is above the atmosphere, so a lot of disturbances due to this atmospheric noises and everything will not.
Can you discuss some of the most recent insights or discoveries we have made about asteroids through spacecraft missions?
Coming to spacecraft missions, actually spacecraft mission always give a direct insight into the asteroid's nature, characteristics, and its structural material. And there are a lot of spacecraft missions that is going on around the world. And notable ones you can say is JAXA's Hayabusa 2 mission, which was completed on December 2020 towards the end part of 2020. And it has collected samples from asteroid Ryugu, which is an important asteroid because it has it is believed that it is a type of asteroid that might have helped Earth in getting its current atmosphere, hydrosphere, etc. So when the research was ongoing for this, when the sample has been analyzed, it has shown that it is having a lot of amount of organic matter in it, and also it was having water-rich minerals, hydrated minerals, which was having a high degree of water in that. So it somehow helps the theologist. It somehow helps in stating the theory that Earth's oceans, majority of the Earth's ocean has been contributed by asteroids collision. So that is another part. And now coming into the second mission, which is one of the famous mission, was Dawn's mission that was provided by NASA. Actually, they have explored two of the more major asteroids from the asteroid belt, that is Vesta asteroids as well as Ceres asteroid. On analyzing Vesta, it was observed that Vesta has undergone a differentiation deformation, and that has helped in having a mantle crust as well as a core. It is almost like a protoplanet.
What are some of the current challenges faced by researchers studying about asteroids, and what the technologies and approaches may be needed to overcome these challenges?
Challenges that scientists all over the world is facing, I would say, the one is the limited sample availability, because to obtain a pristine sample of a particular asteroid, it is very difficult. Almost all nations are trying to get samples, but the thing is that not all can afford sample return missions, which is very much expensive. So all scientists may not have accessibility to these samples. So obviously their research programs will be at a less pace when compared to other advanced nations. And second thing is that diversity of asteroids. Suppose if we have a sample, we are analyzing a sample of a particular asteroid, we'll have the data, we'll be able to process it, and we'll have an entire idea of that asteroid. But that will not give a clear idea about the other asteroids actually, because these asteroids are highly diverse kind of, these asteroids are a highly diverse type of celestial body. So we cannot say that having a data about a particular asteroid will give an idea about the other asteroids. For this, a comprehensive approach is required, which requires a lot of study. And third one, you can say that remote sensing challenges. Suppose almost all these data, apart from the space sample return missions, is based on remote sensing, either by telescopes or by infrared telescopes or by space telescopes, etc. But these are all light reflected or some type of reflected surface, reflective type of data. Means it will have a limited data provision, limited data information. So advancement need to be done in all these areas.
What role do you believe asteroids will play in future space exploration and commercial endeavors, particularly on those of resource extraction and asteroid mining?
See, whatever commercial explorations or endeavors we are going to talk about are still in the early stages of its development. So it is not that it is established now, it will be getting established in the future. One thing we can say is the resource extraction from the asteroids. Asteroids, as we have already discussed, are very much rich sources of metals like nickel, platinum, aluminium, and rare earth elements, in fact. So they also contains water and other volatiles. So if used properly, suppose if you are going for a space mission that is for a duration of 30 days, that will be used based on earth-based resources. Suppose these asteroids can provide all these resources from their surface itself, then we can have a longer duration, 60 days, 70 days, it can expand, our duration can expand, and as a result of this we'll get much better data. So that is one area of usage of asteroid, one area of use of asteroids. And second thing, you can say that in situ research utilization, that is ISRO is actually a type of technology that they are trying to develop into. This asteroid can serve as fuel filling stations itself. For example, it is having a huge sources of water, and that can be used to produce hydrogen and oxygen, which can in turn use as a propellant. So that is one area that development is going on. Then you can say that space manufacturing is another one. Suppose if you are able to use the same raw materials from the asteroids, then we can manufacture required spare parts for these space missions. We need not depend again on earth-based resources. And also one important thing is to continue this scientific research on these asteroids, so that we will have much more data regarding the origin of the universe.
Can you discuss some of the most recent insights or discoveries we have made about asteroids through spacecraft missions?
Most of the areas of asteroid research, we have already touched all these topics in the previous questions. Actually, you can just, again, we'll brush up through that. One, you can say the origin and evolution of the solar system. To know the asteroids, it's like an indirect way of knowing our evolution of the solar system, the celestial bodies, how they have developed, because asteroids have played a prominent role in that actually. And coming to the second area of research, again, we have dealt with certain asteroids which are very much hazardous to the Earth because of their pathways, because of their composition, structural composition, etc. So if they have a direct impact on our Earth, it will have a huge disaster. So for that, mitigation technologies has been developed. But again, this is again under the development. Whatever mitigation technologies like disruption, which uses targeted explosives, that is again under development. Whether we will be able to use a minor quantity of explosive to create that much quantity of explosion, etc. So that process is again under area of research. And third one, which we have again discussed, actually, utilization of volatile resources and in situ resource utilization, ISRO, utilizing volatile resources, organic matter or water as life supporting system for the spacecraft missions, and also whatever available resources can be used as a fuel production, propellant refueling, etc. So development and areas of research is also playing a prominent part in this point too.
Thank you so much, sir, for sharing your experience on asteroids and the research taking place at BARC. We greatly appreciate your time and your invaluable insights.
Thank you.